Hello, and welcome to the IV tutorial, which allows you to compute the pore diameter. A color-coded light in the top right corner indicates the app state. Yellow means computation or file upload is in progress, and green means operation is complete and the app is ready. Now let's navigate to the IV Data Import and Analysis panel. This section manages the loading and initial processing of current voltage data files. Data format selection allows for multiple file types to be uploaded. Auto, generic automatically identifies the format of the uploaded file. Text/CSV, specifically for data exported as plain text or comma-separated values. Excel, for data exported in standard spreadsheet formats. We are going to load an example IV dataset. This file is included with the application. Click the Load IV Data button to select a file. The file name will automatically populate the file name edit field. Once loaded, a preview of the raw data appears in the main figure section to visualize the graph before analysis. Afterward, set the voltage and current units using the Voltage Unit and Current Unit drop-down menu to match the units in the loaded file. This selection will dynamically update the axis labels of the plot and the Vmax and Vmin fields. The Vmax and Vmin fields are editable and govern the voltage range used for the fit. If you select Auto Compute Size and click the Fit Model button, the application will compute the pore diameter using the options in Model and Parameters, Cylindrical Settings, Conical Settings, and Chemical and Physical Parameters panels. Plot button will create an pop-up plot of the IV curve. Now let's look at the settings that define how the application calculates the conductance from the IV data. Choose which part of the data to analyze using the Conductance Mode drop-down menu. All points. Single fit fits a single line through all data points. Positive/negative only extracts conductance specifically from the positive or negative branches of the graph. Average calculates the average of the positive and negative branch slopes. Then, select the mathematical approach for the curve fit using the Fit Method drop-down menu. Linear, standard ordinary least squares. However, this can be sensitive to outliers. Bi-square, a robust regression method added to reduce sensitivity to outliers. Afterward, click the Fit Model button to fit the data. Now let's navigate to the Chemical and Physical Parameters panel. This panel allows the user to enter the experimental conditions required for accurate pore size calculations. Fields include electrolyte, temperature, pH, pK, site density, relative permittivity, and Stern capacitance. These are used to compute the surface conductance term and, if needed, the solution conductivity. Now let's navigate to the Model and Parameters panel. Users must define the physical geometry of the pore to translate conductance into pore diameter. Pore geometry. Select the model that matches the physical pore. The drop-down menu includes options for conical, cylindrical, conical lumped, or custom formula. The conical model treats the nanopipette as a true geometric cone. In this framework, we recognize that the radius is not constant. It tapers from a wide shank down to a tiny nanoscopic aperture. This model calculates total resistance by integrating the incremental resistance along the entire length of the pore. Use this when you need a high-fidelity representation of the physical pipette. The conical lumped model is a strategic simplification. Rather than performing complex calculus to account for a changing radius, it lumps the entire geometry into a single equivalent parameter. This model replaces the tapering cone with a theoretical cylinder of radius. This effective radius is mathematically derived to produce the exact same total conductance as the actual conical pipette. This is ideal for rapid data fitting, circuit modeling, or when the exact taper angle of your pipette is unknown. Custom formula selection activates the Custom Formula panel, and the formula of interest can be entered in the formula text area. This takes the standard MATLAB command form, and an example is included with the application. Users must click the Validate Formula button to ensure the input follows MATLAB formatting. If incorrect, the app will suggest the correct format to enable accurate calculations. Depending on the choice of formula type, length and radius edit fields will get activated. For the first formula type, where radius is expressed as a function of conductance, The length becomes enabled when a formula is entered into the formula text area. Let's input a formula, then validate it using the Validate Formula button. Afterwards, let's input 5 as the length and click Compute Pore Size button. This computes the pore radius and diameter using the conductivity and conductance inputs in Model and Parameters panel. For the first formula type where conductance is expressed as a function of radius, both the length and radius options become available. Let's input a formula, then validate it using the Validate Formula button. Afterwards, let's input 5 as the radius and 10 as the length and click Compute Conductance. The corresponding conductance will be displayed in the conductance field. Now let's go back to the Model and Parameters panel. Help option. Each model has a help button that explains the specific assumptions and formulas used for that geometry. Conductivity. Users can manually enter a value or check Auto Compute Conductivity. This automatically calculates the conductivity based on ion mobility and the chosen electrolyte in the Chemical and Physical Parameters panel. Conductance. This value is automatically populated after clicking Fit Model, though it can be overridden manually if necessary. Include surface term. When selected, the surface conductance is taken into account. Include access term. When selected, the access conductance is taken into account. Now let's navigate to the Cylindrical Settings panel. This panel is specifically for cylindrical-shaped pores. The input fields in this panel get activated if cylindrical is chosen as the pore geometry in Model and Parameters panel. Set the pore length in nanometers using the pore length field and select the desired access resistance model using the Access Resistance Model drop-down menu. Now let's navigate to the Conical Settings panel. This panel is specifically for conical-shaped pores. The input fields in this panel get activated based on the selected conical pore geometry. When conical is chosen, pipette angle, radii ratio, and length factor get activated. The radii ratio is the base radius divided by the tip radius. The length factor is the factor by which the product of the tan of pipette angle and tip radius is multiplied. When conical lumped is chosen, only the pipette angle is enabled. Click Help for more information. Now let's navigate to the Plot Settings and Output panel. The section manages visual display and data preservation. Allows customization of marker type, marker size, font size, line width, limits, and grid styling. Users can save their preferred visual styles to an Excel format using the Save Preferences button and reload them for future sessions using the Load Preferences button. Now let's navigate to the Calculations panel. Clicking Export saves all parameters used, such as pH, temperature, conductivity, and plot settings, to a multi-sheet Excel workbook. Reset clears all entries and resets fields to default values. Compute Pore Size button computes the pore size based on your inputs. Now let's navigate to the Output panel. This shows the surface charge density, pore radius, pore diameter, radius from the lumped model, and the diameter from the lumped model. This brings the tutorial to an end. Thanks for watching.